Okay, so look at your summary of the organic reaction. Okay, in that summary of the organic reaction that was given to you, listed all the chemical reactions of all class of the compound that we covered in our syllabus. We start with the first class, which is alkane, right?
Yes.
Okay, number one is alkane. How many reaction that we have for alkane? How many reaction or how many process?
Two.
There are two reactions, right? The first one is the combustion, second is the halogenation reaction. And then we have alkene and the list of all its reaction, haloalkane. And then we have a nitrile, we have a alcohol. Okay, for the fourth class of compound, and then carbonyl, carboxylic acid, and we last before that benzene. Okay, and then the derivative of benzene, which are methyl benzene and phenol. Okay, that are all that we covered in our syllabus. Okay, so we will referring to this table of the organic reaction, okay, all the time. Okay, and we will follow all the reagents, conditions, and also the products, okay, that is in the table. Okay, so now let's move to the first class of the compound that we want to discuss, which is the alkane family. Okay, when we discuss any class of a compound, okay, firstly we have to know nomenclature, how to give name to the molecule. Okay, then we'll discuss on the physical properties, little bit on the physical properties of that class of a compound. Okay, and then how to prepare it. Okay, the reaction to prepare it, chemical preparation. And then what is the reaction, okay, that they can undergo. Okay, and finally the mechanism of that class, that reaction. Okay, the mechanism of this reaction. So if you look at to your, come back to the table. Okay, if you look at to the alkane, look at to the most right column, type of a reaction. Okay, there are two type of a process. Okay, there are two process. If you look at to the alkane there, combustion and halogenation. However, in the type of a reaction, we only have at the second process, right? At the second reaction, which is halogenation. Okay, so the type of the reaction there, which is the mechanism, is FRS. Means that we just discussed the mechanism, okay, for the second reaction of alkane, which is halogenation, not combustion. Okay, only that we covered in our syllabus. Okay, don't worry, we'll discuss that later. Okay, so this is just the introduction on the alkane. Okay, it is alkane are aliphatic hydrocarbon, okay, that have a C single C and C single H only in the structure of the alkane. Okay, alkane will have a general molecular formula of the CnH2n plus 2. Okay, CnH2n plus 2, in which N is an integer, like it is 1, 2, 3, 4, 5, and so on. Okay, it is contain linear and also branches chain of the carbon. Okay, and they are all saturated hydrocarbon. Okay, why they are saturated hydrocarbon? Because we said that we only have a C single C and C single H in our structure of the alkane. Okay, under alkane, we also have a cycloalkane. Okay, it is actually the carbons that are joined in one or more rings. Okay, when the carbons are joined, are attached in a ring, okay, with the general formula of CnH2n, they will have less 2 hydrogen than the aliphatic or the ordinary alkane. Okay, cycloalkane will have a general formula of CnH2n, while the aliphatic alkane is CnH2n plus 2. Dia ada extra 2 hydrogen. Okay, cycloalkane kurang 2 hydrogen. Okay, this is the example of cycloalkane. When we have 3 carbon, it will have 6 hydrogen attached to it. So the black atoms, they are carbon. The white one, they are hydrogen. Okay, this is 1, 2, 3 carbon, so that the name will be cyclopropane. We add cyclo at the front. When we have 4 carbon in a cycle, okay, in a cyclic compound, it is cyclobutane. 5 carbon, it turns to cyclopentane. 6 carbon, cyclohexane. We just add prefix cyclo at the front when we have this cycloalkane with the general formula CnH2n. Okay, nomenclature, how to give name to the alkane. Okay, firstly, we have to identify, we have discussed this, right? Firstly, we have to identify the parent chain. Okay, which is the carbon or the chain that have a longest continuous carbon. Okay, chain yang paling panjang sekali carbon dan bersambung. Then we say that they are the parent chain. And then we give name to the parent chain. Okay, and then we have a suffix indicate what functional group is present. But when we talk about alkane, the suffix is always "ane" at the back. A-N-E, ane for the alkane. Okay, and then prefix. Prefix tell us the identity. Okay, and then the position, the location, number 1, number 2, and how many branches or how many substituents. Substituent is the same as the branch. Okay, how many substituent that is attached to the parent chain. Okay, start with the parent. Okay, just summarize back. We start to identify the parent chain. Okay, and then we check what is the functional group. This is the general nomenclature, included other family. Identify functional group and then decide what is the suffix that we should use. Alcohol, the suffix will be all. Aldehyde, suffix will be al. Okay, for alkene, suffix is "ane." And then identify the branches. Okay, do we have halogen or we have a methyl group, ethyl group? Okay, and then what is the position or location? It is at carbon 1, carbon 2, carbon 3. Okay, and how many substituent that we have? We have 2 methyl group or we have only 1 methyl group or we have 3 ethyl group attached to the parent chain. Okay, that is what we need to have in our prefix. Okay, so to have a complete name of a molecules, we have prefix and then parent name. If let's say the longest unbranched carbon has 10 carbon, so that it will be that. Okay, and then suffix according to the functional group, so it will be decane in this case. Then we will have a complete name of a molecule. Okay, so this is the example that is given. Okay, when you draw the structure, you are not allowed to leave your structure like this without H. Okay, we don't have hydrogen here because we are learning how to write the name. But if let's say you have to draw the structure, if you have no H or you like in only one H, then you will lose your mark. Okay, because one structure normally has only one mark. Okay, you have to have complete hydrogen that is attached to each carbon so that each carbon achieve octet. Okay, so the first step to give name to the molecule is to find the parent name. Okay, so to find the parent name, we have to identify the longest unbranched carbon chain that are continuous. Okay, so in this case, we take this as a parent. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's either this is the parent chain or we try other possibility. If we go this way, okay, 1, 2, 3, 4, 5, 6, 7 only. So confirm that this is the correct parent chain. Okay, so 8 means that the parent name will be octane. And then identify the branch that we have. Okay, 1, 2, 3. Okay, so this is methyl because of 1 carbon, methyl 1 carbon, and this is ethyl 2 carbon. Okay, this is the first carbon 1, 2, 3, 4, 5, 6. So it will be 2, 6 dimethyl, 5 ethyl. We follow alphabetical order, right? 5 ethyl, 2, 6 dimethyl octane. Okay, and then when we want to identify the parent chain, it doesn't matter if the chain is straight or it is bent. Okay, boleh jadi chain kita macam ni. Okay, or it is bent. Ataupun dia pusing-pusing macam ni. As long as they are the longest one and they are continuous, then they are still the parent chain. Okay, even if we try to draw the structure C, 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 C naik atas balik macam ular dah kan. As long as they are continuous, they are still the parent chain. Okay. And then if let's say they are two chains of equal length. Okay, for example, in this case, okay, we try to identify the parent chain 1, 2, 3, 4, 5, 6, 7. Okay, maybe this is our parent chain. Okay, or we try to have other way. Okay, 1, 2, 4, 5, 6, 7. Okay, also 7. So there are two possible ways, okay, for the parent chain with the same number of carbon. Okay, so which one that we will choose as the parent chain is the one that have more substituent. Okay, if we follow this purple, pathway, then we only have one substituent attached to the parent chain. But if we follow the red one, okay, we will have two substituent, okay, which are methyl and ethyl. Okay, that will be substituent or branch of the parent. So we will choose this as the parent chain. Okay, table 5.2 in a page of 139. Any of you have bought the textbook?
On the way.
On the way, dah beli dah lah. How much?
30 berapa tah? Tak ingat.
I don't think that it is 25. Melainkan dia second hand lah. Saya rasa dia memang macam 40 ni to 40 lah.
30 lebih, tak ingat. 37 or 39, tak ingat lah.
Okay, so if you have your textbook later, you can refer to this table 5.2. Okay, this table 5.2 is the names of alkyl group. Okay, so refer to that later when they are the branch. Okay, we have a methyl, ethyl, propyl, isopropyl. Okay, if let's say the branch, okay, I show you the example. If the branch is CH3, CH2, CH3, CH2, CH2. It is then attached to the parent chain. So this is the branch. The name will be propyl. Okay, because we have, yes, propyl, propyl, they are the same. Because we have 3 carbon there. Okay, but if we have parent, okay, and we have a 3 carbon as well, okay, but their arrangement that are different. Okay, when we have a CH, CH3, CH3. Okay, see the different. 3 carbon in a straight chain, okay, 3 carbon, but it is in a branch. So this one is not known as a propyl only. You have to know that, you have to differentiate these two. This is propyl only, and this is isopropyl. Okay, we also have a butyl, isobutyl, butyl, third butyl. You have to memorize that. Okay. That one you can refer to table 5.2 later. Okay, some of the physical properties of the first 20 members of alkane. We have seen this before. We have discussed this. Okay, from methane, okay, carbon 1 until carbon 10, and then carbon 11 until carbon 20. Little bit on the physical properties. They are gases at the room temperature until carbon 4. Start carbon 5, they are liquid until carbon 17. Carbon 18 start to have a solid state. Okay, so we observe that the melting point increases, boiling point increases, density also increases with the increasing number of carbon in a chain. Okay, little bit physical properties on the alkane. Now we move to the next part of this subtopic of alkane. Okay, how to prepare alkane, how to synthesize alkane. Okay, there are two methods that we can use. Okay, there are two methods to produce an alkane. It's either industrially or experimentally that we can do it in lab. Okay, industrially ni is how they produce alkane in industry, no? Okay, so let's look at to the industrial method to produce alkane. Okay, is through catalytic cracking process. Okay, we have a petroleum. Okay, it is undergo catalytic cracking. So example is given here when we have a C15H32 turns to 2C2H4, 1C3H6 and 1C8H18. Okay, so if we look at here, the starting material is C15H32, right? So if you look at the general formula, what is this C15H32?
Alkane.
Okay, it is also an alkane, right? Okay,
Yeah.
CnH2n plus 2, kan? So this is actually the long chain of alkane. So the catalytic cracking basically is to break the long or the large member of the alkane and produce the smaller members of alkane. Okay, but we also have a side product of this catalytic cracking in which from the long alkane or the large member of alkane, it produces C2H4. This is alkene. And then C3H6. This is also
Alkene.
alkene. Okay, and then C8H18.
Alkane.
This is the alkane. Okay, this is one of the method to produce alkane. Now we are focusing on alkane because we talk about how to prepare alkane. Okay, so this process of the catalytic cracking will take place at the high pressure and high temperature with the presence of the catalyst. Okay, one of the example of the catalyst that is used during this catalytic cracking is the Al2O3, but we have more than this actually. Okay, it is occur at high temperature, high pressure with the catalyst. That is why the name is the catalytic cracking. Crack, pecah kan? Okay, proses pecah menggunakan catalyst. Okay, that is the first one. Number two, okay, how the alkane can be produced experimentally in lab is through the catalytic hydrogenation reaction of alkene. C double bond C. Okay, this is alkene. When we have an alkene undergo catalytic hydrogenation reaction. When we have a term of the catalytic, means that this process require catalyst. Okay, hydrogenation means that hydrogen is used during this process. So we have a ethene here, CH2CH2, that is reacted with the hydrogen, okay, in the presence of the Ni, nickel, PT or PD. Okay, so what happens is the alkene turns to alkane. Okay, you also can look at to this reaction, okay, under the compound in your summary of the organic reaction of alkene. Okay, open your summary of organic reaction, look at to alkene, the reaction of alkene. Calculate how many reaction of alkene that we have. How many reaction that we have in a table, class?
6.
Okay, we have halogenation 1, hydrogenation 2, hydration 3, hydrohalogenation 4, mild oxidation 5, strong oxidation 6, right? So look at to the second one, hydrogenation reaction of alkene. Okay, name of the reaction is hydrogenation. The reagents is H2 gas. Okay, and then in our table, we are using nickel as catalyst in the presence of heat. Okay, so we just follow the table since our table said that we use nickel and heat. Okay, so it will then produce alkane. Okay, another example of this hydrogenation of the alkene, let me show you if let's say we have other members of alkene, CH3, CH2, CH3, double bond, CH2, double bond CH, CH3. Reacted with the H2 in the presence of nickel and heat. Okay, so this what happen is the hydrogen will be added, okay, to these two carbon so that it will produce, okay, CH3, CH2, CH3, single bond, CH2, okay, H down there and CH3. Okay, from alkene, it turns to alkane. Okay, when reacted with H2 in the presence of nickel and lead as a catalyst. So these are two methods to prepare alkane. Okay, first catalytic cracking, second is catalytic hydrogenation from alkene. Okay, finish with the preparation. Okay, this is the next part, which is the reaction or chemical properties. Okay, so the alkane is originally low, called as a paraffin, low affinity, because it is inert towards most of the reaction. It is very hard for the alkane to be reacted. Okay, that is why it is known as a paraffin. Okay, not so many reaction that we have for alkane because it is saturated compound. Remember that? Okay, so there are only two reactions, okay, on the alkane that we'll discuss. The first one, alkane undergo combustion reaction, and second is the halogenation reaction. Okay, so when alkane combusted, okay, we have seen this last time when we want to determine the empirical formula in our Chem 1. Okay, when we have a hydrocarbon compound reacted with the oxygen, which means they are undergo combustion, then the mass product are carbon dioxide and H2O. Okay, so in this case, we have ethane here, CH3, react with the oxygen. Okay, then it produces carbon dioxide and H2O. So what's important in this first reaction is you have to be able to balance the equation, to give the balance equation from your starting material. Okay, it can be butane, it can be pentane, hexane, and so on. Okay, so if it is hexane, then what is the coefficient for the oxygen that is used? What is the coefficient for carbon dioxide that is used? And what is the coefficient for the H2O that is used? Okay, that's the important thing that you have to be able to do when you will be answered about the combustion reaction. Okay, balance the equation. Okay, you already learned, okay, this balance equation in Chem 1 in your secondary school. So I think that you have no problem with that. Okay, but still, okay, if you are not sure and you want to use the formula method, it is listed in the textbook, page 145. Okay, when the formula is given to you, let me rewrite here. The formula is CXHY, okay, plus with X plus Y over 4 of O2 turns to XCO2 plus Y over 2 H2O. Okay, which one that you prefer? You want to memorize this formula, X plus Y over 4, Y over 2? Okay, or you just want to use the method that you have applied before to balance the chemical equation. Okay, that is on the combustion reaction. And then the second type of a reaction for alkane is the halogenation reaction. The name is halogenation reaction because we will react the alkane with halogen. Okay, so the halogen that we use, okay, it's either chlorine or bromine in the presence of UV. Okay, then we will get the haloalkane as a product. Okay, and this halogenation reaction become a chemical test of the alkane. What is the meaning of a chemical test? If we want to test the presence of alkane, if let's say I have a compound, okay, in a beaker. This is X. I don't know what is X. Okay, and then then you have to identify what is X. Okay, then you can predict, oh, X may be alkane. Okay, X may be alkane. So if you want to confirm whether X is an alkane or not, so you can react this X with the halogen. Okay, or it can undergo halogenation reaction to confirm whether this is alkene or not. Okay, that is the meaning of a chemical test. The reaction, okay, that we use to identify or to confirm a specific compound, a specific class of a compound. Okay, and this halogenation reaction also needs a UV. Okay, in the presence of UV, then it can happen. It can produce this haloalkane. No UV, no reaction. Okay, so halogenation of alkane is actually the substitution reaction. Okay, it is actually one of the substitution reaction. Okay, with the bromine or chlorine in the presence of UV or sunlight. Okay, what is the purpose of UV? It will provide the energy, okay, for the production of the free radical. Okay, the halogen will absorb the energy to produce a free radical. We look at that in the mechanism after this. Okay, since that we said that it is a chemical test. Okay, when it is a chemical test, okay, means that there will be observation, okay, that we can see. Okay, so if the reaction is positive and we are using bromine as our halogen, the observation will be brown color of bromine is discharged, because bromine is brown color. If it is true that X just now is an alkane, we react X with the bromine, and then suddenly the brown color of bromine is discharged, then it will confirm that X is an alkane. Or we also can react it with the chlorine. We know that chlorine is yellow in color. So if X is alkane, so it will discharge the yellow color of chlorine. And another one side observation is the production of the white fume. Okay, we can see the white fume produced. That is for the HCl gas. Okay, that is formed during that reaction. So kalau if you are using bromine, only one observation. But if you are using chlorine, there are two observation, the yellow color of chlorine and also the white fumes of HCl form. Okay. Now we move to the mechanism of a reaction. Okay, if we have a reaction, the chemical equation, the general chemical equation for this reaction is actually CH4, okay, reacted with the Cl2, UV, and it turns to CH3Cl plus HCl. This is the general chemical equation. Okay, but besides or behind this general chemical equation, okay, this reaction, the production of the CH3Cl is actually undergo in three steps of mechanism. Okay, in which we start with the initiation step, and then propagation, and last with the termination step. Okay, if you got a question, write the mechanism of the free radical substitution reaction. Okay, the name of the mechanism is the free radical substitution. Okay, you have to start with the name. Okay, kena ingatlah nama setiap satu step ni. Okay, the first step is initiation, second is the propagation, the third one is the termination. Okay, so what happened, the initiation step is the cleavage occur. Okay, in halogen. Okay, this is the step that require UV just now. If there's no UV, no cleavage occur. Okay, and these two atoms of chlorine, okay, from our halogen here, will undergo homolysis. Okay, it will undergo homolysis so that it will produce, in the presence of UV, it will produce two radicals of chlorine. Okay, this is what happened in the first step. If let's say we are using bromine, so in the first step we will have Br, half-headed arrow turns to 2Br radical. Don't forget to have UV. Okay. And then the second step is the propagation step. Okay, in this propagation step, what happened is the radical that is produced in the initiation step start to attack the hydrogen in the starting material or in the alkane. Okay, the radical will start to attack the hydrogen because it is free radical. It does not achieve octet. So they akan looking for any ways for it to achieve octet. So the chlorine radical attack hydrogen, okay, and then it takes hydrogen attached to it, turns to the HCl. Okay, what happened when the H is attached to the chlorine, turns to HCl, it will make the CH3 that is left become radical. Okay, and then we start to have other radical species. Then we will have other propagation step in which the radical that is produced here, CH3 radical, will attack the neutral Cl, the neutral Cl2. Okay, Cl2 yang tak undergo lysis lagi. Okay, so Cl2 is then being attacked by the CH3, in which one of the chlorine will then attach to this CH3. Okay, and then another one chlorine will turn to Cl radical. So it will produce CH3 Cl plus with one Cl radical. Okay, if we have a sample, okay, you have to understand the process. If we have a sample, it is not necessarily when you add chlorine with the CH4, okay, what happened in the first 5 seconds is only initiation. Okay, and then the next period will be propagation only, and the next period only termination. Okay, it is not necessarily. Even after the propagation start, we still have other initiation that is happen. Okay, we also have a termination that is happen at that time. Okay, this process is occur okay, throughout the time as long as the sample are in a container. Okay, dia bukan ini je start dulu, lepas tu stop semua initiation and then propagation sahaja, not necessarily. Okay, chlorine radical yang ada dekat sini boleh start balik reaction propagation. Okay, sebab molekul kita bukannya ada 2 molekul je dekat dalam kita punya sample. If you are using contohnya 1 mole, so see that we have 6.022 times 10 power of 23 molecules there that needs to undergo all these 3 steps. Okay, so if I try to show, okay, other molecules beside methane. Okay, so if let's say I give you other reaction by using bromine, okay, propane for example, CH3, CH2, CH3 that is reacted with the bromine, okay, so that it will turn to CH3, CH2, CH2, Br. Okay, when bromine start to attach to one of the carbon, it's either it is attached to this carbon or this carbon. Okay, both are possible. Okay, so if it is attached to the first carbon, so what happened in the propagation step is Br radical that is produced here. Okay, Br radical will start to attack CH2, CH2, CH3. Okay, from our propane here. Okay, so this Br radical attack the H. So what happened? H will attach to the Br radical. It will make these turns to radical. Okay, so the product will be HBr plus with CH2, CH2, CH3 radical. Okay, and then the next step of the propagation, just like this. Okay, this radical is then attack the Br2 molecule. Okay, so we will have radical of CH2, CH2, CH3 react with the Br or Br2. So one of the bromine attached to this carbon, another one turns to radical. So the product will be CH2Br, CH2, CH3 plus with Br radical. Okay, this is happen in the propagation step. I show you another example by using bromine. And then the last step, which is the termination. In the termination, what happens is the free radical will attach to other free radical. So we have, in this case, in this initial example, Okay, we have two type of radical, CH3 radical or chlorine radical. Okay, so the first possibility for determination is when chlorine radical attached to CH3 radical so that it will form CH3Cl, or CH3 radical attached with another CH3 radical so that it will form CH3CH3. Okay, or it will form ethane. And then the third possibility that will happen in determination when two radicals of chlorine attach together so that it turns to Cl2. Okay, so when all radical attack with another radical, then it will lose their free radical journey, then they will turn to a neutral compound. Okay, so if we try to write the termination step for this example, okay, for this reaction propane with the bromine, okay, so determination, the first one is possible for the Br radical meets another Br radical so that it turns to Br2. Then it is possible for the CH2, CH2, CH3 radical, okay, to mix with another radical of CH2, CH2, CH3, okay, so that they will turn to CH3, CH2, 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 CH3. Okay, so from propane now they turns to hexane. Then the third possibility is when Br radical that is attached to CH2, CH2, CH3 radical so that it will turns to Br, CH2, CH3. Okay, question? Okay, this is an example when we have a reaction of the ethane with the chlorine. Okay, the mechanism. So the general equations for this reaction is actually CH3CH3 plus with the Cl2 UV, so it turns to CH3 CH2 Cl plus with HCl. Okay, this HCl is the white fumes too. Okay, only if it is reacted with the chlorine, then we will have this white fume of HCl. So look at the process, they are the same. Okay, always start with the initiation step when the halogen undergo homolysis in the presence of light. Okay, and then it turns to two radical of chlorine. Okay, and then the radical of chlorine in the propagation step start to propagate or start to attack the hydrogen in the ethane. Okay, so the cleavage occur here. See, this is also homolysis. Okay, when this part turns to radical, okay, and then chlorine get the hydrogen to form the HCl. Okay, this HCl is the product here, the white fumes. And then the next step is this radical that is produced in the first propagation step, okay, attack or react with the Cl2 neutral. So one of the chlorine attached to it, so it turns to the product as well, CH3, CH2, Cl. This is the product, our main product. Okay, and one Cl radical produced. Okay, so the steps are repeated again and again. Okay, this propagation step are repeated again and again. And then finally, the indetermination step when the two radicals attack to each other so that we will get back our Cl2. Then the new product or the side product, okay, will be, here is butane. Okay, and this is our main product, which is chloroethane. Okay, but we don't show this in our general equation normally. Okay, because we are focusing on the main product that we want to get through this substitution reaction. Okay, because the main reaction, what we are focusing in this reaction when we react alkane with the chlorine is actually the substitution reaction when the alkane turns to haloalkane. Okay, we are not focusing on the other alkane that might be produced, okay, as a side product of a reaction. Okay, but still you need to know that, okay, it has other side product. Question. Okay, so those that have a textbook, okay, you can look at to the page of 149. Okay, determination steps that might happen if we have excess of the methane and also chlorine. Okay, we have excess chlorine, we have excess halogen. Okay, either chlorine or bromine. We can have more than 2 steps of the propagation. Okay, so if let's say we have methane reaction CH4 that is reacted with the chlorine in the presence of UV, we know that usually we just put it as CH3Cl, in which one of the hydrogen replaced by the chlorine. Okay, so that the product will be CH3Cl, okay, and HCl. Okay, however, if we have excess chlorine, we can have more than 2 steps of the propagation. Okay, we know that in the propagation step, step number 2, propagation. Okay, firstly, the Cl radical will attack CH4. See, I expand the structure of CH4. Okay, so this chlorine will take one of the H, so that it will turns to HCl plus with the CH3 radical. Okay, and then the CH3 radical will attack Cl2 neutral, so that it will turns to Cl radical plus dengan CH3Cl. Okay, the Cl start to attach to this side. Okay, and then after this is produced, if the chlorine in excess, this is only happen if the chlorine in excess. Otherwise, we just stop here. Okay, but if the chlorine in excess, okay, we will have other propagation step in which chlorine radical can attack this product. Okay, CH3Cl. So if it is attacked CH3Cl, okay, so it will take another one H, okay, the second H in the structure, okay, so that it will turns to HCl plus with the ClC radical H. Okay, so when we have this radical, it is then react with the chlorine neutral. Okay, Cl. ClH radical react with the chlorine. Okay, so that it tends to ClC, chlorine attached to it. Okay, that replace this radical position. Okay, H plus Cl radical. See, now we start to have dichloromethane. Okay, then this process can proceed more. Okay, we have this other Cl radical that will attack this. Okay, then it turns to ClC ClH, it will take one of the H. So now it turns to Cl radical H plus with the HCl. Okay, and then this one, Cl radical H react with other neutral chlorine so that it turns to CCl H. Now this is trichloromethane plus with the Cl radical. Okay, and then we have another propagation step. Okay, Cl H. Okay, react with other chlorine radical. So it turns to Cl radical plus with HCl. Okay, and then the final step is we have a Cl radical react with neutral molecule. So it will complete the octet of the central carbon. Okay, when the carbon receive the last chlorine attached to it. Okay, now it turns to tetrachloromethane. Okay, and the chlorine turns to chlorine radical. Okay, so this is the final products that will produce if the reaction is occurred in excess. Kalau soalan mention, okay, what is the possible product? Okay, what is the possible final product if the substitution reaction occur in excess chlorine? Okay, kalau soalan tak ada sebut pasal excess chlorine, they just sebut in general, means that the only product will be this lah. We just stop the propagation step until these two steps, okay, until step number 2, the first step and second step. Okay, but if it is in excess, okay, or the substitution occur to all hydrogen that we have, okay. So finally, okay, from methane, it turns to chloromethane, and then it turns to dichloromethane, and then it turns to trichloromethane. Finally, it will turn to tetrachloromethane. So when we have a lot of these propagation steps, it means that our termination step will be more as well. It is not just 3 steps as before. Sebab kita start to have many other radicals that are produced. Okay, dia akan start ni possible to attach with this. Okay, it is also possible to attach with this. Okay, so many possibility. Okay, but normally we just focus on what is happened to the methane, okay, after it is undergo substitution with excess chlorine. So ni final product kita lah. Takkan ada lebih daripada ni.
Madam tanya, maksud propagation tu maksudnya
Okay,
dia nak kembang sampai kembang lah. Maksudnya dia nak jadi, macam dia kata, kalau bahasa sedang Google dia kata propagation tu maksud dia